Welcome to Cosc Aerospace. On this video I'm going to be talking about flight controls and the different directions that it's able to move the aircraft about the three axes of the aircraft. Before I proceed, I'd like to thank those who subscribe to my channel, Cosc Aerospace. For those who have not subscribed to my channel, I'd like to encourage you to subscribe to be able to get updates on new videos. The flight control surfaces that I'm going to be talking about are the rudder surface, aileron, elevator, flaperon, flaps, slats, canards, and spoilers. The rudder surface is a surface which is mounted aft of the vertical stabilizer on the rear spar, and this surface is actuated by use of the rudder pedals, either pushing the left or right rudder pedal in, and this will enable the aircraft to move left or right in the directional manner about the normal axis, which is an axis which moves from top to bottom about the center of gravity. The next control surface is the elevator. The elevator is a control surface which is mounted aft of the horizontal stabilizer on the horizontal stabilizer aft spar, and this control surface is actuated by movement of the control yoke or the side stick forward or aft, depending on which direction of motion that the pilot requires the aircraft to move into. This is achieved about the lateral axis, which is an axis which moves through the center of gravity left to right, and the other surface is the aileron and the flaperon. The aileron and flaperon assist the aircraft to achieve roll maneuver about the longitudinal axis, which is an axis which moves from the nose to the tail about the center of gravity. This is achieved by moving the control yoke or the side stick left to right. That's causing either right or left aileron or flaperon to move up or down, changing the lift characteristics of the wings, either high lift or low lift on either wings. Thus, one wing drops and the other rises, causing the aircraft to either roll left or right. The other surface that we see in a few other aircrafts are canards. Canards are mainly seen in aircraft which are of a delta wing configuration or an ogive wing configuration, and these are surfaces which are mounted on the nose section of the aircraft and also operated by the control yoke or side stick by movement fore or aft, thus causing the aircraft to pitch up or down about the lateral axis, which is an axis that is moving through the center of gravity left to right of the aircraft. The other surfaces that we find also in other aircrafts are rudder vettors. Rudder vettors are control surfaces which are a combination of rudder function and an elevator function. These are mainly found in high-performance fighter jets, such as the F-18 Hornet or the F-14 Tomcat and other types of aircraft which require high performance and high maneuverability. The other surface that we find in the delta or the ogive wings are the elevons, which combine elevator and aileron functions, and these maneuver in different directions, either up or down or up or down in different directions if you are operating it in a function of an aileron, and they're able to move up and down in tandem if you are operating them as elevators to achieve pitch control. Thus, these surfaces cause the aircraft to act in both pitch about the lateral axis and able also to cause the aircraft to achieve roll about the longitudinal axis. The other surfaces that we have are spoilers, which are mounted on the upper surface of the wing in between the slats which are on the leading edge and the flaps on the trailing edge. Spoilers can serve different functions. Spoilers can be used as flight spoilers. For a case whereby they're used as flight spoilers, they can assist. They act also to assist in roll control, and they can also be used as speed brakes in flight to deter the lift and also deter or reduce the lift, causing the aircraft to achieve high descent rates when required. The other type of control that some aircraft have are non-conventional, such as thrust vectoring. This is the use of exhaust nozzles, which can be moved in either a three-dimensional or a two-dimensional kind of maneuver. This causes the aircraft to achieve flight control without use of the flight controls, or together with the flight controls to augment the flight controls. On the three-dimensional type, the aircraft is able to be maneuvered in all the three axes. That is, the nozzles are able to move in such a manner that they'll cause the aircraft to turn about the normal axis, able also to cause the aircraft to pitch about the lateral axis, and able also to cause the aircraft to roll about the longitudinal axis. For the two-dimensional thrust vectoring nozzle, mainly seen on the F-22 Raptor, the aircraft is only able to achieve a pitch maneuver by shooting the nozzle up or down, thus vectoring the thrust in that direction, and able to cause the nose of the aircraft to either pitch up or down about the lateral axis. The depths of space, we have a different type of control, which is the use of retro rockets, which are miniature rockets mounted on different positions of these projectiles or space vehicles, and this enables the projectiles or space vehicles to maneuver in the depths of space and in the vacuum of space, whereby normal aerodynamic flight controls will not function. These are mainly seen used in the warheads or the kill vehicles used in ICBMs before they re-enter into the Earth's atmosphere, to be able to orient these warheads in a direction that is required to impact the coordinates that have been given for this projectile to fly into. These are also used in space vehicles such as the Space Shuttle to maneuver it in space and orient it in a manner before the normal propulsion system is able to push the aircraft in that direction. The other surface that we see used in the normal aircrafts are slats and flaps, which are mainly used to augment the lift of the aircraft. They're able to increase the lift of the aircraft during low speed flight, and thus enable the aircraft to approach for landing at a lower speed, and thus enable the aircraft to be able to decelerate in a manner that won't use up much runway on touchdown. I'd like to thank you all for being part of Cosco Aerospace. If you're not subscribed, please subscribe to this channel, be able to get updates on new videos, and be able to harness more on aerospace and aviation.